Okay, so as I was saying before, so we have compound events. Sophia, put it away. So we have compound events. So this is when we're having multiple events occurring. Okay, so we want something to occur and then another thing to occur. Compound events is then broken down into independent and dependent events. Independent events is when each event, one event does not affect the next event. Okay, so example here I have is with genders. When you have one baby, the sex of that baby does not affect the sex of the next baby the person will have. Okay, it could be the same thing with rolling a die. So if you roll a die and you get, say you get a 3, doesn't mean the next time you roll you won't get a 3. Okay, every roll is independent of each other. Then we have dependent events, is when one event does affect the other.
Good morning, Rob Bethel. Can the following grade 9 students please come down to the cafeteria? Sherilyn Abraham, Anthony Alexis, Sophie Ball, Avery Barnett, Natalie Bevan, Kiara Barcelino, Cassidy Brown, Sebastian Cavallero, Hannah Carroll, Olivia Crispo, Olivia DeMatos, Emma Dempsey, Isaac D'Souza, Maya Demal, Sebastian Demetrio, Nicholas Doyle, Kareem, ignore that one, sorry. Sienna Gomez, Lexi Kiosis, Luke Loberg, Nicholas Racanelli, Carter Thompson. Those students, please come down to the cafeteria. Thank you.
Okay, and the formula for independent and dependent is the same. It's the probability of A occurring times the probability of B occurring. Okay, so I have 4 mic markers in my pocket. I have 2 black, 1 green, 1 blue. Okay, I take one at a time, and then I put it back in my pocket. Okay, so what is the probability I will use a black marker and then a black marker again? Okay, so we want probability of A and B. In this case, it would be black and black. So the probability of black occurring times the probability of black occurring again. So if I were to randomly reach into my pocket and pull out a black marker, what is the probability that will occur? What is the probability that will occur? Yaba? Sorry? One of close. How many black markers do we have? 2. Okay, so we pull it out. We have 2 black markers. Remember, it's the number that happens over the total. So 2 black markers we have over the total of 4. If you said 1/2, that is fine. Okay, but I'll reduce at the very last step if we need to. I'm not gonna reduce at every step. Okay, so I use the black marker. Let's just see the video, and then I put it back into my pocket. Okay, so how many markers do I still have? I still have 4 in my pocket, right? So each event is independent. Okay, so if I have 2 out of 4 chance first time, what is the probability the second time? It's the same because I put it back. Exactly. So it's still 2 out of 4. So I put B and B because we're looking at black and black. Okay. So if you want to put a K there to distinguish between black and blue, you can. Okay, refresher, how do we multiply fractions? Going back to elementary school, but often forgotten. How do we multiply fractions? Take a guess. How do we multiply fractions? Okay, so we multiply the numerators together, so 2 times 2, and then we multiply the denominators 4 times 4. Okay, so numerators together, 2 times 2, and then denominators 4 by 4. So we get 4 over 16. Okay, and a reminder, there's the calculator, the button that reduces for you. Or if you just know, what is 4 over 16 reduced to? Sabrina? 1 over 4. So we divide each one by 4, you get 1 over 4. And then that would be your answer. Okay, reminder, probability can be written 3 different ways. Okay, so one is fraction. Give me the second one. Ratio's odds. Ratio's odd. I guess you could, but I'm looking for a different one.
Decimal.
Who said it?
Decimal.
Decimal. Okay, and the last one? Percentage. Okay, so you only need one. You don't have to put all 3. So 0.25 or 25%. Okay, next one. So same question. So what is the probability of picking a blue marker out and then a green? Okay, so there's the and in this question. So we want a blue and a green. So the probability of blue and green, probability of blue occurring, I'll put BL for this one, times the probability of green occurring. You do not have to write the formula out every single time you answer a question. Okay, so what's the probability that I reach out of my pocket and I pull a blue marker? What's the probability or chances? Sabrina? 1 over 4. Okay, so I have 1 blue marker out of a total of 4. So I remove the blue marker, I use it, I put it back into my pocket, and now I want to randomly pick out a green one. Okay, what's the chance of green now? Cassandra, right? 1 over 4 as well. Okay, so times 1 over 4. Okay, now we multiply again the numerators and denominators. So we get 1 over 16. Questions? Okay, second question. So we get, what is the chances of flipping heads on a coin and rolling an even number on a die? So first we want to know flipping the heads and rolling an even number on a die. So we want the heads and the even number. So we want probability of heads and put E for even. So the probability of flipping a heads times the probability of an even number. Okay, so look for these key words when you're having the questions. Is it say an and or does it say an or? because if you don't pick the right formula based on the words, then your answer is incorrect. So question with the first question, first one, was this independent or dependent? Independent, right? So independent because each event did not affect the next. Okay, and these don't affect each other. Flipping a coin or rolling a die, they have no effects on each other, so each event is independent as well. Okay, so if I flip a coin, what's the probability they'll land as a heads? What's the chances? Can't hear you. Six. So what's that? 1/2, good. So there's one heads out of possible two answers. Okay, so 1 out of 2 options. 2 options are heads or tails. Times, okay, an even number on a die. Okay, a die has 6 numbers. How many are even, Sophia? 3 out of 6. Good. So we have 2, 4, and 6. So we have 3 out of 6. If you want to put 1/2, you can. Okay, but again, I'll reduce at the end. So 3, 1 times 3 and 2 times 6 gives you 3/12, which is 1/4. Again, these are independent events because one does not affect the other. Okay, move up. What's still writing it? Okay, last question. Okay, a bag contains 3 chocolate Oreos and 3 vanilla Oreos. If Adam randomly chooses a chocolate one first and eats it, what is the probability that he will choose 2 in a row, including the first one that he ate? And then B, 3 in a row.
Good morning, Robert F. Will the following grade 10, 11, and 12 students please come down to the cafeteria? Shay Afolabi, Olivia Boateng, Evangelos Angelou, Anastasia Fenley, Tahir Hall, Naya Jackson-Williams, Madeline Cash, Remy Lyons, Brian Amaral, Madison Brownlee, Chiara Canini, Lucas Cannon, Aaliyah Akabuchi, Cassandra Martinez, and that's it. Thank you.
Okay, so a bag again contains 3 chocolate Oreos and 3 vanilla. Adam picks out a chocolate one and eats it, and then want to know what's the chances that he chooses another chocolate randomly. So it's 1 chocolate and then another chocolate. Okay, so it's an and, so we have multiplication. Let's give it a minute. Okay, so that's first. I reach in a bag and I put my hand in, I take out a chocolate Oreo. What is the chances that I did that? What's the chances that it's chocolate the first pick? Sophia? 1 out of 2, or without reducing? 3 over 6. You're both right. Okay, so I'm just gonna do it without reducing, so 3 out of 6. I'll reduce at the end. Okay, so 3 out of 6. He eats the chocolate. Now he reaches back into the bag, and then what are the chances he pulls out another chocolate Oreo? What is it now? Kate? 2 out of 5. Good. Because there's no longer 3 chocolates, there's only 2 chocolates left, and there's only 5 cookies in total now. So this becomes dependent. Okay, this is dependent events because after he eats one, my totals change, my probabilities change. So originally it was 50%, now it moves us down to 40%. So we multiply them, we get 6 out of 30. Reduces to, who has this one? Sabrina?
1 over 5.
1 over 5. Good. Okay, now we're adding a third one to it. Okay, we already know the first two. The first two answers were 3 over 6 and 2 over 5. So 3 over 6 times 2 over 5. Guess we already did 2 chocolates here, so we'll just copy that over. And what would be my last fraction? Be my last fraction. How many chocolates remain after I ate 2? Sabrina? 1. Okay, and I ate 2 cookies, so what's my totals now?
4.
4. So 1 out of 4. Again, multiply all the numerators together and all the denominators. So we get 6 out of 30 times 4, 120. And when you reduce it, 1 over 20. Okay, that's the lesson for 1.5. Homework is here. Page 53. I'll write on the side 1 to 4, 5A, 6, 8, and 10. Okay, so the next 25 minutes. And for those who are watching online, the review, not watching online, the ones I recorded. So the review is posted online, but I'll just write it out.